I'm sorry. So what we're going to do here is the tools for success, the animations, flowcharts, animated flowcharts specifically. We want to look at the choosing between Z and T, because I know that this issue started out in chapter 7, but it remains with us throughout the rest of this time that we see the T distribution and the normal distribution. And so there's a flowchart, and I'm not going to go through all the slides. There are 22 slides if you want to check them out, and they go through several examples, but they essentially say that when you start the process to decide which distribution to choose, you have to ask yourself, do you know the population standard deviation? See, the fact is there are many books out there that don't even follow this kind of argument. They just realize that for all intents and purposes we're always going to be using the T distribution, because if we knew sigma, it would be kind of ridiculous to talk about trying to create a confidence interval or a hypothesis test to find out what the mean would be, since if you knew sigma, you had to have known mu, the population mean, to have found sigma, right? So they're just doing the T distribution all the time. But our author teaches us how to, first of all, use the normal distribution, which we're used to from chapter 6, or you're familiar with, I should say, and apply that to the process, and then apply that process to the T distribution. So here they talk about a sample of 35 adult men. Now that's already a good thing for us if we're choosing between the distributions. Anyways, the sample size is 35. We've got their mean height, and we find the standard. Let's see, does it say the standard deviation? No, it doesn't. It says, and the standard of this sample is 3 inches. I guess that assumes standard deviation. But that's of the sample, and they try to emphasize that, first of all, because at the beginning of the sentence it says that it's this sample of 35, and then second of all it says that the standard, and they mean standard deviation of the sample is 3. Okay, so we have S, we have little s. We don't have the population standard deviation sigma. Now, as I went through the chart, though, I acted like I didn't know. The question, do I have sigma known? I will say yes, that sigma is known. And then they say that's incorrect. And it's incorrect because, sigma was not known, right? Okay, follow. So I follow down that path of no, we don't know sigma. And then, is the population normally distributed? Well, I'm going to act like, again, that I'm wrong. I'm going to say, yes, it's normally distributed, although let me just double check here. It says that a histogram showed that the sample is approximately bell-shaped. So let's go ahead and say no, that it's not normally. And then they say that's incorrect again. Down the yes path. Point here where then the question is, was the sample size greater than 30? Well, it was, but that didn't matter because the sample was normally distributed. Does that kind of make sense? Anyway, so go through the remaining slides there, and if sigma is known, you follow down this path, which could take you to using the standard normal distribution, or if the sample size is too small and the parent population isn't normally distributed, could end up being basically a dead end for us, because when it gets to the point where it says you're going to have to use bootstrapping methods or non-parametric methods, it's a dead end for us right now. So you'll either use Z if the requirements are met, or you'll use T, and this flowchart is an excellent way to go in and out of practicing. So definitely please check out the remainder.